Hi there, thanks for tuning to my YouTube channel, the CNC Dude YouTube channel. Today I have a cool project. I mean, it's not something alien technology or we're gonna save the world tomorrow, but you know, baby steps. What I have here is a box, it's an enclosure, and we're gonna put some demo boards, electronic boards, high voltage. That's why we need it to be enclosed, and obviously to reach the internal, the guts from the outside, we're gonna need to put some connectors and different items. So of course I gotta drill holes. It's not just holes actually, it's more like pockets, contours. And you know, 50 or 60 years ago, this may have done by hand, you know, with a Dremel. Maybe you glue in your template, and with a Dremel very slowly you carve it. Some people are artists of that art, and that's great. That's a way of doing it. I'm a cheater, so I'm going to use my CNC milling machine to obtain gorgeous results. And most importantly, we can repeat the same process, and we get pretty much the exact same result. And I think that's the main idea behind today's video. It's about repeatability. Because I gotta make 3 of these boxes. Now on my introduction video, I said that I hardly ever make more than 1 or 2 parts. And usually when I make 2 is because the first one is a mistake. So the second one is the one that actually works. But I gotta make 3 of these boxes, which means that I'm gonna have to find the edges, pretty much locate the box with regards to the machine blade, and then do the cut. Now I gotta do that 3 times, but I also have to do it on this side and then on this side for a different feature. That pretty much means that I would need to find the edge 6 times. I am not thrilled about changing tools 6 times just to find an edge. So I'm gonna use a trick. It's basically nothing new, nothing super duper fascinating that you haven't heard of before. It's basically called a work stop. I'm gonna use a work stop once I have found my zero to ensure that I can retain my zero once I flip this part, or even when I remove this part and I put a new one. What that will allow us is to pretty much remove the part, put a new one, press start. Remove the part, put a new one, press start, and it goes. So I don't need to be changing tools, I don't need to be finding my zero, it's all taken care of. Now the best way to see this is to actually see this. So let's go and see this. We're ready to start finding the edge of my box. So I'm gonna put the box in the vise. First thing is just remove this blade, which I was using on a previous endeavor. And I'm going to use the edge finder. Now I know this edge finder is 200 mils, if I'm not mistaken. This is 200 mils, thousandths of an inch diameter edge finder. That means that when I find this edge, I'm actually finding the center to be away 100 mils from this edge. So take a look here quick. Not certain if you can see that. Yeah, 200 mils. So let's put it in. Find the edge, and we will set our DRO to determine in both X and Y where is 0, 0, so that we can start cutting these puppies. This is the box I'm going to be working with. As you'll see, the features are going to be cut on this side of the box. So I gotta make sure this is the back side of my Y. So this point is 0, 0, like this. 0 in X, 0 in Y. Or this is 0 in Y because Y is like this, and this is my 0 in X because X is like this. And then we'll find the 0 on Z, but that's when the tool is on place. Then I have to flip the box, and I have to maintain these zeros as I explained before. Now this is a plastic box, which means that I cannot just crank this as if it was a piece of aluminum or steel. I gotta be careful, otherwise I'm gonna shatter it. But at the same time, I don't want it to be too loose, because otherwise it may become untangled from the vise, and that would be the end of it. Most likely we're gonna cut where we're not supposed to cut. So very dangerous situation for the box, not for us. But since I only have a limited number of boxes and I need to provide at least 3 for tomorrow, let's get it right. I think that's good enough. I'm gonna find the Y0 by touching on this surface, and then the 0 on X by touching on this surface. For this edge finder to work, it has to be rotating at 1200 RPM. So that's what I have set up my 0 here, my spindle speed at 1200 RPM. And let's get it going. I'm gonna press F5 to turn it on. Lower it and see. Now I'm on top of the part, so I gotta get away from it. I need the edge finder to move in Y positive, C negative. And now I'm going to start moving the box towards the edge finder, or the edge finder towards the box. And when I see it flicker to the side, that's my 0 point. And then I have to put in my DRO positive 100, because that means positive 100 mils, because that means that my 0 is 100 mils away from the actual 0. I'm going to use the spindle on very slow speed, and then eventually on step mode, so that I can get to the actual place where my 0 is located. Okay, it flipped, but I'm a little bit away, so I'm going to retract. Now I know where it is, and now I'm going to use step mode. That's it. Now I'm assuming that my Y is 100 mils away. So I have made my Y 100 mils positive. To verify this, we can go away from 0, and if I type now G0, Y0, it is going to move to what is actually the 0. So the center of this guy is on the edge of that guy. Alright, now we can look for the X0. Obviously, I gotta move my box a little bit more towards the back, so that I can actually get access to this surface. So that will be Y negative. Now we're gonna go in X. I'm gonna get very close. X positive. And that is the point in which the edge finder moves. That means that is my edge, but now I am on the other side of X. So right now, my 0 is negative 100 mils. So let's put minus 100 mils on the DRO for X. Minus 0.1. Okay, in order to corroborate, I can move my C up and type G0, X0, and it will go to the actual edge. Alright, now, my X and my Y are 0 for that box. But eventually I'm going to take that box away, and I'm going to put either the same box or another box, and I don't want to repeat that process. You just saw how long it takes. And it's not that it takes forever, but if I can get rid of that process, that step, even better. So I'm gonna use the worst stop. This is the worst stop that I use for this kind of jobs. It's basically a made-in-home worst stop, and you know, I acquired this worst stop with the machine. When I bought the machine, and I bought this CNC milling machine, the Tormac, used. Basically, I bought it from a gentleman here in Dallas, Texas, and I'm super lucky to have found this amazing deal. The machine was basically new. He had only done like one pocket, one hole on a piece of fiberglass. Other than that, everything was like brand new. So it was a tremendous deal, and I was super lucky to acquire it. But this gentleman, unfortunately, he has some health issues. I guess that's how our hobbies die eventually. So he couldn't keep up, and I was lucky to acquire that. And he gave me these plus a bunch of other knickknacks. And you know, it's not the ultimate in worst stop technology, but it will get the job done. So that's all we care. We'll put this on the T-slot. And the idea here is, maybe I'm going to use this T-slot. And you know what? I'm going to move this guy up a little bit. I'm going to need a wrench. That one. You know, this may look like a poor man Allen wrench, Allen socket wrench toolbox. It's actually the place where I put all of the Allen wrenches where I find no other place. But I actually have good sets that are complete. My 3-year-old is saying hi. He wants to be on YouTube.
That's not uñas.
Uñas. Okay. I'm not certain what he's saying yet. Anyway, I'm certain we'll find one Allen wrench in here. No offense to the creator of that worst stuff, but man, that was quite a hassle to get it in position. It almost makes me wonder if one of our future projects will be to make a new worst stuff. But luckily, I have one of the Tormac Vises on its way, so chances are that I'll just use the one that comes with the one that I ordered that goes with the Vise. In the meantime, we are set. The worst stop is actually in place, and I think I have a good pressure against the box. So when I remove this box and I put the other one, the 0 on X and Y will be preserved. Do note, however, that even if these positions have not been preserved, it's not the end of the world, because it may be, let's say they are 20 mils away, which is not the case. I know it's not the case. But even if they were 20 mils away, for this project, it's not a problem. For some other projects, like if you want stuff to align, bolt bearings, axles, that is kind of a more important one. So in those cases, we may actually need to find the edge on a continuous basis or get a fixture that is a little bit better than this. But for this project, no issues. Now I can put the cutter and we can start getting some chips. For this work, I'm going to use 1/125 inch cutter. It's basically 1/8 of an inch. That's what I'm going to use, and you know, I've done it before and it looks pretty good, the output. It's the thinnest cutter that I have. Ideally, I would have used something thinner, because then I can get even more features. Some of the features I'm actually going to have to file, which I'm not super proud of, but I don't have a thin enough cutter, so that will have to do. This is my 1/8 of an inch cutter. And of course, before this happens, I need to find the 0 in Z, the Z axis. For that, I'm going to touch off, and you know, just by sight, I'm going to determine this is my 0. Again, this is not alien technology, what I'm trying to do here. In fact, I have instructed my G-code to go 1/4 of an inch deep, because I know that will be more than enough to carve the hole that I need. Remember, the depth on this project is not important. What we're trying to do is cut the sides, a contour, and as long as the blade is completely in, that's all that we care for. So if my set axis is 5 mils too high, or it's just applying pressure to the plastic, that is not going to be the end of the work. But you got to be mindful of this, because in a particular project it may be important. For example, if you have parts that have to align on top of each other and the depth is crucial, then you have to ensure that your zero is the zero. And there are different ways of doing that, but for this project, touch off and my eye will be more than enough. I guess my eye, because I'm only 41, if I was like 80, maybe that would not be enough. But luckily, I haven't hit that spot yet, so I can trust my eyes. I'm gonna sit down, and by looking at the reflection, I see when both images meet, and that's pretty much it. Yes. I'm gonna say that's my zero. Again, it's not crucial. If it isn't, the project will still work as intended. I'm gonna take it up. I think we're ready to press start. Now I have to load my G code. I haven't done that yet. And as soon as I load my G code, we can press start and it will go. So that's next. Alright, I have loaded my G code. I think we're ready to proceed. I'm kind of freaking out here. It happens to me all the time. It's like, man, I think I have checked everything. And, sometimes I think that I have checked everything, and still there is something that I haven't checked, and it's all goes to hell. But I think we're ready to proceed. If not, this will make for such a funny fail video. One important note before I start. In this job, I have two processes, two two-dimensional contour processes, but they're going to run at once. The machine is not going to stop for me to press start again, because it's going to be using the same tool. If you want the machine to stop, whenever you finish one process to go to the next, you have to specify tool number 1 as tool number 1, or any number. It could be 10 or 15, whatever. But tool number 2 must be a number different than tool number 1. Why? Because otherwise it will go and they will just jump from first process to the second process. And it has happened to me where I start with a 1/2 inch mill, and then I'm supposed to go to a 1/4 inch mill, but I forget to change the number, and what happens is that the second process is not going to work well. It would be okay if you were going from a 1/4 to a 1/2, because then you would try to do that which is big with something which is smaller, so nothing would be damaged. You could just go back, edit your key code, and get it to work. But if you're going from larger to smaller, that's gonna be a problem. So always be mindful of that. That's a typical mistake that I make every now and then, and that is one of the reasons why every now and then I have to make 2 parts just to get one. All right, I think we're ready. Let's press start. Now the first time I press start, it will just basically go into the beginning of the G codes. So the first G codes are for preparing the machine, and then we can start with the actual code. Now we get it started. Let's see. Just like I explained before, if the part is not subjected properly on the vise, all hell breaks loose. And all hell has broken loose, damn it! Now, the part is away from the zero, so that means that all I have to do is move it away, move it into the work stop, and we're in good shape. I think the problem is that I'm going too fast. And I remember when I was doing this work, I set my working speed at 18 inches per minute. That may be too fast, so it's not giving time to cut. So I'm gonna have to make changes to my camming work and start this. It's very possible that this box is messed up, so unfortunately that's just how it is. I'm gonna give it a try one more time just for sake, but I think this is toasted. You know what? I'm gonna go into the G code. I'm gonna change that IPM of 18 to something like 12 because I think that's gonna help. So I go here to change G code, and somewhere in here, here's my feed rate, 18. I'm gonna change that to 12. And I have to do that down here as well. Hopefully that works. Now I do file, save, file, exit, cycle start, and let's hope for the best. Yeah, that was it. So it came out good. Now, two things that happen here. Man, if I had a nickel for every time that compressor scares the crap out of me while I'm recording a video. Okay, you know, this is polycarbonate, so we're gonna have to sand this a little bit. But what I wanted to show you was the place in which I made basically the mistake. This notch in here. So I don't know if that's gonna fly. I think it will be okay, but I may need to can this box. The other problem that happened was that a big block of plastic became untangled on the, basically it melted and then solidified on the blade. And that caused some rubbing action in here. That's not pretty, but I think the connector will actually hide this. So that's, I think that will be okay. I'm gonna try the connectors in here and see what happens. And then I'm gonna continue cutting these because I want to make sure that everything is fine before I do the other boxes. Otherwise, I'll be, remember, this is going to be very repeatable. So if there is a mistake in here, I'm going to be repeating the mistake over and over, and that's not what we want. Alright, I have had to do a lot of stuff behind the cameras because I basically ran out of battery in one of the cameras, and so while I charged it, I did a few changes. But the important thing is the results, not the in-between, although I can imagine the in-between is interesting as well. What I wanted to show today was the ability to repeat a job and obtain repeatable results without having to continuously be looking for zero. So I have to do this for 4 boxes. I'm going to do it for 4 because the first one is a mess, so at the end I'm going to get 3. And I finally found the right parameters. So this is kind of the useful information for you. I was doing 1800 RPM for my spindle speed and 18 inches per minute for my feed rate. I tried 1200 for my feed rate and I was at 1200 for my spindle speed, and that was too slow. So I think I'm getting good result with 1500 RPM on the spindle. The feed rate was 18, I took it down to 10. So what does all of this mean? I think that at 1800 and 18 inches per minute, the speed of the spindle was so high that I was melting the plastic rather than cutting it, and that resulted on that big blob of plastic blobbing into the cutter, right? And that messed up the surface finish. And then the 18 inches per minute were just too fast, so there was not enough time to remove material, so the blade was actually pushing the part out of the vise. I could have added more pressure into the vise, but that could have resulted in the material crackling. It's uncertain, I don't want to get there, but I think with 1200 RPM, 1500 RPM, and 10 inches per minute, I'm getting good results, repeatable results. So now all I have to do is slide my box in the vise. I'm going to slide it until I'm touching the work stop, and now I can close this. Now I gotta make sure that I'm putting it in the right place, because I have some features on the back. I already added with the laser engraver. I added where the holes for mounting the board are going to be. So let me make sure I have this right, and we'll get started. The feature that I'm going to build is this one, the 2 holes, and I'll show the finished thing at the end. But I gotta make sure my 4 mounting holes are here. You cannot see this obviously, but I gotta make sure the 4 mounting holes are here, and yep, that's what I have. So this is the side of the feature that we're going to work on now, and I have the program loaded. I am against the worst stop, so as soon as I press go, it will go and I'll get what I need. Now I'm going to run the program twice, and the reason is that the first time there's going to be a lot of junk on the sides here, so I'm gonna when I run for the second time, I'll clean it up a little bit. It's not even a minute, so we're in good shape. Looking good. I have a lot of junk in here, so here is a cool tool that you can use to clean that up. Man, it's like butter. Looking very good. And of course I have to dust it now, but these are the cavities that I wanted to get. Excellent. Now all I have to do is take the other 2 boxes, fit it in, and press start twice. I mean, it's just as simple. I don't need to be rehoming every time. Well, mission complete. I was able to make 4 boxes with 2 pockets for the USB connector, 1 pocket for the IEC connector, and another pocket for a connector that I don't have, but it will fit in there. This was a great opportunity to showcase how you would use a work stop on a CNC milling machine. But let me add that you really do not need. That the work stop is not necessarily a CNC thing, right? I mean, it's not like you only use a work stop on CNC milling machines. Actually, you can use a work stop in any piece of equipment that you can think of. It could be a drill, a lathe, a saw, or even a manual milling machine. So don't just assume that because we're using this in here, this is only meaningful for CNC milling machines or CNC equipment. But this was a great experiment to show, a great project to show the advantage of actually having a work stop, because now I was able to put my 4 different boxes into the vise and get the repeatability that I was looking for without having to find the edge on a continuous basis. And let's remember that the machine doesn't know where the part is. You have to tell it. I mean, the machine doesn't have the capability of determining that the part's a little bit to the left or a little bit to the right. It just doesn't know. It doesn't have an eye to look at the workpiece or the environment in which it's going to be working. Perhaps in the future, such a technology will be available, and CNC machines will have computer vision that will let them know whether the part is a little bit off and adjustment needs to be made. But as of today, I'm not certain that feature is available in CNC machines. I'm positive it doesn't exist on hobby CNC machines, but perhaps it exists on industrial CNC equipment. I'm not aware of that. I do know, however, that pick and place machines, like the ones, pick and place machines, the ones used to build PCBs by placing small components on top of a PCB at astounding speeds. They use computer vision to determine if the board is a little bit off and if they have to adjust the component. Those are usually multi-million-dollar machines, extremely sophisticated piece of equipment, cutting edge, and really I wouldn't consider them a CNC machine, although you could argue that in a sense they are. But you really don't machine anything out of it. It's basically just for putting components on top of a PCB in this case. Well, this was a great project to showcase the repeatability of a CNC milling machine. I mean, of course, you can do the same with a manual milling machine, but it's just going to be tougher. As you were able to see on the video, it's just a matter of pressing a button and place your part one after the other, and it goes. If I had 100 boxes, it would have been the same 100 times. So very easy to do. Hope you have learned something from this video. Feel free to comment. And I guess I'll see you the next time. Have a good one.